Concepts on trains are very simple. See, the only thing you have to do is when a train crosses an object, what is the distance it travels? Suppose if there is a bridge, if a person crosses the bridge, what the distance traveled by the person means it is nothing but the bridge length. But if a train is crossing the bridge, what happens? This is the engine, this is the last bogie. When we say the train crossed the bridge, when the last bogie crosses only, we'll say the train crossed the bridge. Suppose if you observe, engine was originally here, now engine here means what is the total distance engine traveled? This plus this is the bridge length, this is the train length. That's why we say when a train crosses a bridge, we say the distance traveled is length of the train plus length of the bridge. If it crosses a tunnel, length of the train plus length of the tunnel. Or if it crosses a platform, length of the train plus length of the platform. Or if it crosses a man, if a train is crossing a man, the distance it travels is only the length of the train, because length of the man, like bridge, length of the man has no significance. So hence we say only length of the train. So that's why I can sum up this like this. When a train crosses a point, a man or a pole or a tree, it's a man means just a point only, then it is only length of the distance covered is only the length of the train. However, if it crosses a bridge length cannot be ignored. That's why we say when a train crosses a bridge or a platform or a tunnel, the distance covered is length of the train plus length of the bridge or platform or tunnel. Right? Then the question is, what if one train crosses another train? See, it's like a bridge only. So see, if it's instead of a bridge, if it is another train, when a train crosses another train, what is the distance means? It is same, the length of first train plus length of the second train. Instead of a bridge, I have another train. Then somebody will have a doubt, what if the other train is also moving? If it is moving in, suppose same direction, what happens? Opposite direction, what happens means, students, as far as the distance is concerned, when a train crosses another train, the distance is length of both trains. Whether the other train is moving, if moving in what direction it is moving, they're all required to write the relative speed, what we have discussed in the previous concept, but not to write the distance. Distance is fixed, whether they go in the same direction or opposite direction. First of all, whether the other one train is moving or not moving, right? So please remember, all that is required only to write speed, not to write distance. These are the key points on trains questions. Now let us discuss a couple of examples on trains. A train running at a speed of 54 km per hour crosses a man in 20 seconds. How long does it take to cross a 450-meter long bridge? Right. When a train is crossing a man, the distance it travels is its own length, and the speed at which it is traveling is 54 kilometers per hour. That is 54 into 5 by 18. 18.3 is 15 meters per second. And the time it taken is 20 seconds. You know the speed, you know the time. Distance is equal to speed into time. So 15 into 20, 300 meters is the distance. But distance is nothing but length of the train. So length of the train is 300 meters. Now, if you look at the question now, how long does it take to cross a 450-meter long bridge means, when a train crosses a bridge, the distance it travels is length of the train plus length of the bridge. Length of the train is 300. Length of the bridge is 450, totally 750 meters, and the speed at which is traveling is 15 meters per second. You are asked to find the time. Time equals to distance by speed, 750 by 15, 50 seconds is the answer. This is the basic method. But however, I can directly say like this. If speed is 54 km per hour, if I convert into meters per second, as I have already explained you, you will get 15 meters per second. Now, when a train is crossing a bridge, it travels length of the train and length of the bridge. But when a train is crossing a man, it travels only length of the train. So for that, it is taking 20 seconds. To cross a man means to travel the distance of a train, it takes 20 seconds. When it is crossing a bridge, it has to travel train's length plus additionally what? Bridge length. So in the second case, the extra distance it is traveling is this 450 meters. You can see here, it is 300 here, it is 300 plus 450 means it is traveling 450 meters extra distance compared to the first case. For that, how much extra time you require? So distance is 450, speed is 15 meters per second means 450 by 15, 30 seconds extra time I require compared to the first case, because I have to travel 450 meters extra distance. So hence my answer will be 20 plus 30. I can say 50 seconds directly. Right? Let's take one more question. Two trains take 30 seconds to cross each other when they travel in opposite direction. If the faster train takes 80 seconds to overtake the slower train, find the ratio of the speed of the faster train to the slower train. So when the two trains cross each other in opposite direction, whether one faster train overtakes the slower train, both cases the distance traveled is same, that is length of both trains. So hence here the distance is same. When the distance is same, what is the relation between speed and time? They are inverse relation. What is the ratio of the time I have? So the ratio of the time I have is 30 is to 80, that is 3 is to 8. This is when opposite direction, this is when it is same direction. If the ratio of the time is 3 is to 8, the ratio of the effective speed when they travel in opposite direction or same direction will be speed and time are inverse relation, that is 3 is to 8 is the time means speed will be inverse, that is 8 is to 3. But you know, when they are going in opposite direction, it is S1 plus S2. When they are going in the same direction, it is S1 minus S2. So this S1 plus S2 is to S1 minus S2 is equals to 8 by 3. S1 plus S2 by S1 minus S2 equals to 8 by 3 means if I cross multiply 3S1 plus 3S2 equals to 8S1 minus 8S2. 3S1 comes this side, 5S1 equals to minus 8S2 comes here, 11S2. Or I can say S1 by S2 equals to 11 by 5. S1 is to S2 means S1 is the faster train. So the faster train to slower train, the speeds are in the ratio 11 is to 5. 11 is to 5. Is that clear? So the answer is speed of the fast train to speed of the slower train means our answer should be 11 is to 5. You can say 11 plus 5, 16, 11 minus 5, 6, 16 is to 6 is 8 is to 3 only. Right? If the speeds are 8 is to 3, the time will be 3 is to 8. Confirm? So these are a couple of examples on trains. In the next session, we will take up linear races.